Today we're doing lesson 5.13, module 5, lesson 13, and today we've been working with area models, right? Yes, nod your head yes if area models seems like something you've been working on all this week. Good. So today our learning goals, we are going to explain how area models is related to something called the distributive property. And we've learned the distributive property before, but you might have forgotten. How many of you feel that way?
I forgot.
Okay. We'll talk more about what the distributive property is today and how it's related. It's the exact same thing as area models. And we'll take a look at why that is. In your notebook, go ahead and draw this rectangle that you see here. Okay, and we're going to find it using an area model. So you can draw a rectangle where the dimensions are 3 3/4 inches by 1 1/3 inch. When we're going to use an area model, let's split 1 1/3 into a whole number part and a fraction part. What would the whole number part be? 1. And what would the fraction part be? 1/3. What about for 3 3/4? So what would the whole number part be?
3.
And what would the fraction part be? 3/4. Okay, now let's find the area of each little rectangle inside of the big rectangle. For the first one, which is this one, we can see that the dimensions are 3 by 1. So the area is 3 times 1, which is 3. The one right next to it, we can see that the dimensions are 1/3 by 3. So in order to find the area, we'd multiply 1/3 times 3, which is 3/3, which is 1. Very nice. Okay, I wrote it sideways just because I had more room there. Now for this guy down here on the bottom left, we have 3/4 by 1. So to find the area, we do 3/4 times 1, which is 3/4. Very nice. And the following rectangle is 3/4 by 1/3. So to find the area, we multiply 3/4 times 1/3. When I can see that I can cross cancel that. So the answer is 1/4. Very good. Now, over to the right, I want you to write the words partial products. Okay? And then under that, let's write down all the partial products. Our first partial product is 3. Our next one is 1. Our next one is 3/4. And then our last one was 1/4. Okay? And then, of course, to find the total area of the original rectangle, we just add them up. 3 plus 1 is 4. 3/4 plus 1/4 is 1. So we're doing 4 plus 1. So the area is 5 square inches. Now, my question to you, this is what we did for homework yesterday and what we learned yesterday. When we add up those partial products, what property of multiplication are we using? Are we using commutative property and moving things around? No. Are we using associative property and changing which ones we group using parentheses? No. Are we using the identity property of multiplication and multiplying things by 1? No. What we're using is called the distributive property. The word distributive property, and you should write this down in your notebook, sounds like the word distribute, right? Now, in our classroom jobs, who are the people who are in charge of passing things out? They are the distributors. To distribute something means to give it to everyone. When our distributors pass out the papers, do they skip a couple people and say, here, papers for the yellow table, but no papers for the orange table? No. The distributor's job is to distribute the materials to every single person. Okay? So, when we use the distributive property of multiplication, you're distributing different parts of the multiplication problem to each part of the problem itself. So let's take a look at that same problem. To find the area, were we doing 1 1/3 times 3 3/4? Yeah. Are those the dimensions of that rectangle we just drew? Yeah. So that would be the length times the width, right, which would find the area. Now, we could separate 1 1/3 to 1 plus 1/3, can't we? Mm-hmm. And we can separate 3 3/4 to 3 plus 3/4, right? So when we use the distributive property, we're saying that we can multiply 1 times 3 and then 1 times 3/4 because you're distributing that 1 to both parts of the other factor. Does that make sense? Then you can multiply as well. You have to do, we haven't touched the 1/3 yet, so we have to distribute the 1/3 to the 3 and then 1/3 to the 3/4 too. Do you see that? You're distributing both parts of the factor to each part of the other factor. So let's do those problems. We first said we could do 1 times 3, okay? So what's 1 times 3? Okay. Then we have to distribute this factor of 1 to the other part, which is 3/4. So what's 1 times 3/4? 3/4. Then we had to take the second part of our first factor, which is 1/3, and distribute that to the first part, which was 3, right? So 1/3 times 3 is what? 1. And then did we distribute 1/3 to 3/4 yet? Not yet. So next we have to do 1/3 times 3/4, which is 1/4. Then we have to add up all those parts to see what the total is. 3 plus 3/4 plus 1 plus 1/4, which is 5. Do you see how these partial products are the same partial products that we got from doing the area model? So using an area model is just the same thing as doing distributive property. So by doing this, and the reason why we add all of it together is look at what sign is over here. Addition and addition. So in the end, we add all these up, and we get the total area is 5. Okay, so this shows that the distributive property is the same thing as doing the area model. This time, instead of using an area model, which is the same thing as distributive property, let's use improper fractions. We know that we can find the area by doing 1 1/3 times 3 3/4, right? And if I want to multiply that, instead of breaking it apart into 4 different partial products, what I can do is I can just change it to improper fractions and multiply. So 1 1/3 is the same as what improper fraction?
4/3.
4/3. And 3 3/4 is the same as what improper fractions? 15/4. And now in this case, is there anything I can cross cancel?
Yeah.
The 4 and 4 are both divisible by what number? 4, and they both become 1s. And then the 3 and the 15 are both divisible by 3. So 3 divided by 3 is?
1.
And 15 divided by 3 is? So my new problem is 1/1 times 5/1. So my answer is 5 square inches. So in this case, was it easier to break it apart into partial products using either the area model or distributive property, or was it easier to use improper fractions? Improper fractions. Very good. So we can see using these examples that sometimes it's easier to use the distributive property or an area model, and sometimes it's easier to use improper fractions, right? We could see in our first problem that using improper fractions was easier, couldn't we?
Yeah.
But then in the second example, using improper fractions, we had to multiply 33 times 17 and then divide by 8, which is quite cumbersome. And the more math you have to do like that, is that more chances you might make a fabulous fail? Okay, so you have to look at the numbers and try them out and see which way works better. Do you get the same answer both ways? Okay, so you'll have to have some experience to see, oh, this one I should use distributive property, or this one I should use the improper fractions. Does that make sense? And if you really want to be sure and check your work, you have 2 different ways on how you could do it. Okay? Now that we see that, can we see what's the total length from here to here? We have 8 plus what? 3/4 plus 3/4. Does that make sense? Okay. What about from here to here? We have 10 plus 3/4 plus 3/4. So what is 8 plus 3/4 plus 3/4? 9.5 inches. And then what's 10 plus 3/4 plus 3/4? 11.5 inches. So now if we know that the dimensions of the mat are 9.5 by 11.5 inches, can we find the area of the mat? Okay, let's do that. So again, the area of the mat is 9.5 inches by 11.5 inches. Should we use the distributive property or improper fractions? Let's try distributive property. So we know that this is 9 plus 1/2 times 11 plus 1/2. Okay, let's distribute the 9 first. So we do 9 times 11, which is? Okay, let's distribute the 9 to the other part. 9 times 1/2 is? 4 1/2. Good. Now let's distribute the 1/2 to the 11. 1/2 times 11 is 5.5. And let's distribute the half to the other half. Half times half is 1/4. Let's add those pieces up. Let's add the halves first. 1/2 plus 1/2 is?
1.
Okay. Now we have 1 plus 99 plus 4 plus 5 is what? 109. And then we have to add the 1/4. So the total area of the mat is 109 1/4 square inches. Right? Do you see how the distributive property was way easier than trying to convert 19 halves and 23 halves, because then we have to multiply 19 times 23, divide that by 4. Do you see how that is a lot easier? Okay, is that the total answer? 109 1/4? No, because it's asking how much is not covered by the picture. So as we recall, how much square feet is being covered by the picture? 80. So I have to do 109 1/4 minus 80. What's 109 minus 80? Reagan?
29 1/4 in square inch.
29?
29.
29?
29.
And?
29 1/4 square inch.
Thank you. So that's your final answer. Do you see how that works? Very good.